Yes. Okay. So, hello everyone. My name is Pratyush Kumar. Am I audible to everyone?
Yes, yes.
Yes. Okay. So, my name is Pratyush Kumar, and speaking about myself, I has completed my PhD from IIT Bombay, and I have also completed 1 year postdoctoral into the IIT Bombay itself. Recently, I got this SNSF fellowship at the ETH Zurich. So I am soon going to join the ETH Zurich for my uh, means postdoc work, and I'm working on the same problem. So I'm working on the CFD, ML, and pins problem. So that we will, if you are going to join this workshop, then we will discuss it what is the pins and what is the CFD, ML. So this is all about myself. And speaking about this ITRA SIM company, so this ITRA SIM company, we are researchers from the IIT Bombay. We have started this company in 2022. So we have started this company in 2022, and starting at the starting, we have just arranged some workshop in the IIT Bombay, and our main focus was on the open form, because if we see the CFD softwares and CFD background, so if we see the contents related to the commercial software like NCs, so you have there are lots of available resources are available on the internet and on the YouTube. But if we go towards the open source softwares like OpenFOAM, so the contents were very limited. Contents were there. So that is why we started. Means first we have made one team in the IIT Bombay, and we have just created some contents related to the basics, and we have organized 1 or 2 workshop in the IIT Bombay with the collaboration of the some teams of the IIT Bombay, and that workshop was huge success. And after that means I also regularly uploaded open form content and CFD content on my YouTube channels. And when I started uploaded the content, I got many requests from the followers of the YouTube channels that you should also create some advanced programming lectures on the open form on CFD. So from that concept, we have just finished one global level open form hands-on programming workshop last year, and it was also a huge success. So speaking about that global workshop, we our content has been appreciated from the many professors from the IITs also, from the IIT Madras, IIT Hyderabad, and from IIT Roorkee. So they have bought many courses from the Europe and US, and they said that your content was very genuine, and even if you charge us the 3 times amount what you are providing us, we are even going to pay that amount also. So that was huge success. I will say that open form hands-on programming workshop. And after completing that workshop, even those who have attended our last workshop, they have requested us to make one content on the CFD. So those participants has requested us to made one content which is hands-on content related to CFD-ML. So this request has been we are following these requests from last 6 7 months, but now we are in a situation where we can provide the contents related to the CFD-ML. So this orientation sessions, we are going to just explain you that how we are going to means follow the instruction during the course, and what will be free structures, and how we are going to provide you the content. So all questions that you have raised in your mind, we are going to answer those questions. And after the orientation session, I have also and after the orientation session, I have also one session where we are going to learn about the simple form algorithm. Sorry for this disturbance. So after that orientation session, we are also going to have a one session where we are going to learn about the simple form algorithm from the Navier stock equation and the continuity equations. Then we are going to see that how that simple algorithm has been coded into the open form. And I would advise everyone who is going to attend the second session, so not just only open your screen and watch the video. It will be better if you follow the instructions while I am going to do the coding. That is why I have shared one zip file into the WhatsApp group. So please download that zip file in your folder, and if you are attending the second session, then you should follow the instruction strictly. Okay, so let's start our orientation session. So if I speak about the ITRA sim, so although my when I started this company, my mainly focus was related to the open source software. So I thought that there is a very lack in the consultancy and means if we talk about the uh, online tutorial or hands-on training, so it is the very limited the contents related to the open source software. But after means 1 or 2 years, I got many requests to provide the contents or training related to the commercial software. So we are also providing some contents related to ANSYS and some other commercial softwares. But still, our mission was only related to the open source software. So our main goal was to provide the contents related to CFD, that is the computational fluid dynamics, and CFD-ML, that is the computational fluid dynamics and machine learning. And also in future, I'm also planning one course structure that is related to the CFD-DM, that is the computational fluid dynamics and the district element method, who is working related to the packed beds or particles dynamics. That course is related to the CFD-DM. So that course I am planning, and soon I will going to announce on my website, or if I have your email ID, so I will share you the details about that course also. Okay, and the organization is founded by the researchers and educators from IIT Bombay, and even some of the technical advisors are from IITs, who is the professor in the IIT. So like Professor Sandeep Saha, and one is the Naveen Mari Tripathi, who is the professor in the Rajiv Gandhi Technical Institute. So these there are two or three professors who is working as a technical advisor for the ITRA. And speaking about the only, since this is related to the training session and hands-on workshop, so if speaking about our experiences relevant to the hands-on training, so we have conducted 3 times workshops in IIT Bombay. So 2 times we have conducted for the open forum, and 1 times we have conducted for the NCS workshops, where the means faculties, postdoc students, researchers, PhD students, and even some of the bachelor's students has attended this session. So we organize our course structure in such a way that even UG students would get benefit from that, and even if someone is already using that software, those guys also going to benefit from that. And even some of the contents is highly advanced, highly means related relevant to the advanced programming or advanced CFD. So even if some professors are there, they are also going to benefit from those contents. And after that, we also regularly means upload the CFD content on our YouTube channels. So some of the very common topics like if you see that the simple from basic to coding, which is one of the popular video on YouTube, is means watched I think watched by more than 10,000 views on that CFD simple from basic to coding video. And so these are the things that we have already done in terms of the trainings. And recently, I forgot to mention here, recently we have means contacted for the FMFP workshop into the Nirma University. So that was the 2 days workshops, which is organized by the means Nirma University, and I trust SIM members has conducted this 2 days workshop for the open forum. and it was a huge successful. So that workshop has around 30 participants are professor and 30 participants are the researchers and the students, and they have appreciated very much. And that I see as a huge success, because FMFP is one of the international conference related to the fluid mechanics. So if you guys are working on the fluid mechanics and heat transfer, I think you have always come across this FMFP conference. So ITRASIM has been invited for this conference for the two day session. Although it was a basic session, because in 2 days we can only cover the topics related to the basics only. But it was a huge success. And apart from this, we have last year conducted this 40 hours global workshop. So last year we have conducted this 40 hours global workshops. And speaking about this 40 hours global workshop, so one of the professor, I means due to the privacy, I will not mention his name, but he was IIT Hyderabad. He's contacted me, and he first bought one course from the some European institute. He bought that course, means of I think 250 euros, and he got go means he completed that course, and then he watched my video on YouTube channel, and from somewhere from LinkedIn he contacted me through the mails, and he wanted to buy my course. He just asked me that you have any well organized course where you have covered the open form and programming. So I have suggested that, sir, I have already one course which is around 40 hours, and that cost around 8,000, because it was a pre-recorded lecture. So that is why it cost around only 8,000. So he says that, okay, I will buy your course. And after buying that course, he says that if you take me, you have charged me around three times of the 8,000, then that I was going to easily pay you that amount, because that your course structure has so much effectively designed that I am expecting to learn from that course content. And that he says that that European course was completely garbage. And if you see, means you just see, I am also means I am also struggling from first year. So when I started my PhD, I was no idea about the open form, no idea about the C++ programming, and I have also struggled a lot. And I have also buy some courses online, and I see that what those courses were, what things they are missing, and that is whatever that courses are missing, that is completely given in that content. That is the 40 hours global and advanced open form programming workshop. So that the content you can see, and we are going to provide this course if you are going to register for the CFD-ML. So this 40 hours content we are going to provide you at the free of cost. So this is our highlights. Till now we have completed this much sessions. And speaking about the why CFD-ML is important, because if means while I completed my PhD, I was looking for the postdoctoral opportunity. And apart from India, I found that if you have a CFD ML experience, it is very easy for to get either a job or a opportunity like postdoc opportunity, because this is the emerging field. That is the CFD ML is the emerging field, and that has a very means there are very reason, because it has a this is a cutting edge technology. And now this research as well as the careers prospectus, both things are focusing on this CFD ML content. And it means it is making the bridge between the physics and data, because nowadays is, if you know that nowadays now everything is working on the data things. Okay, so if your data you can means make your process very faster. So that is why industries are looking for someone expertise who have both knowledge of the CFD as well as the machine learning, because they want to merge, they want to make a connection between the physics as well as the data they have. So that is why they were looking for the researchers, or they are looking for the engineers who has the both knowledge of the physics and the data. Okay, and this modern era is, as you know, that all about the machine learning and AI. So that is why if you are want to compete with the modern engineering and modern research. So this CFD ML is essential for you. Okay. And these are the some applications I have mentioned here. This is just one or two or three examples. But now this CFD, ML and pins. Pins is one important topic, physics informed neural network. So these things, these two or three. तो हुआ है स्क्रीन पे. ओके ओके. हेलो. स्लाइड चेंज तो हो रहा है. चेंज तो हुआ है स्लाइड. अच्छा अच्छा. अभी दिख रहा है क्या?
Please unmute yourself.
So actually I got a call, so that's why I have muted myself. So I think now you are able to see my slides. So I got some call that my slide is not changing. So is it working now?
Yes,
Uh,
Pratyush, change to the next slide. Well,
Is it working?
now change to the next slide and we'll see if it is working at the moment. Yeah, it is working. It is fine, yes. Okay.
Okay. So means I was saying that I have just mentioned here only two or three applications. That one application is the turbulence modeling, and generally this nowadays ML is mostly focused to means speed up the simulation related to the flow and thermal. And third one is the combustion and reactive flow, because it is a very complex phenomena. So now they are using the pins algorithm to solve this combustion and reactive problems. So these are the three applications I just mentioned here, but it is not limited to only these three applications. Pins and CFD ML problem is being means utilized in many of the CFD applications. Like the project which I was going to work is related to the lead and frost problem, lead and frost phenomena, which is the multi-phase problem. So this is not means my point is that the CFD, ML and pins is not limited to this application only. So now uh, see, the idea is that if you see means if you are working if you are as a researcher and you are working a problem related to CFD, so if you see that CFD is almost become obsolete here. So there is not much of the coding development is going on in the either in means India, or you can see Europe or other countries. Whatever you are doing something, you are working on the application part. Okay, you are not working on something like you are not developing some algorithm, or you are not developing some coding related to CFD. So because CFD has become almost obsolete, so that is why now they are looking for the some faster and some better algorithm. That is where this CFD ML or pins comes into the pictures. And if you see through the means proposals into the top institute like means MIT or ETH Zurich or Stanford University, you are going to find out they are looking for the some researchers who has skills relevant to the CFD-ML, because this is the emerging field. So if you want to do something development, this is the area where you can do the development related to the program, related to the algorithm. And so if we speak about the particularly related to the my course structure, so these are the key concepts that we are going to focus. So we will going to cover the CFD content, and we are going to utilize the OpenFOAM software, because OpenFOAM is the open source. And and apart from that, we are going to look for the some projects which is the integrated with the CFD as well as the machine learning. And this physics informed machine learning, that is the means topic related to the where we are going to couple the physics as well as the machine learning. And we are going to see that how this is different from the this conventional method, that is the computational fluid dynamics. And this physics, what is the advantage of the physics machine informed machine learning compared to the CFD, and why the industries and the researchers are focusing on this physics informed machine learning, that we are going to see in this module. And we have see, our idea is that we only can't cover around 40% tutorial, and we cover more of the hands-on experience projects in our course content. So this contents, hands-on projects, we are going to have more than 60-70% that we are going to work on. And we will also see that how we can do the solver customization. And of course this CFD and machine learning, we will start with the introduction, then we will go to the advanced projects, and then after that we will go to the physics informed machine learning. So these are the key concepts that we are going to cover in this workshop, that is going to around 2 months approximately. And these are the modules that you can see. So we have divided our modules into the 4 modules. And the first module, we are going to start with the basics of CFD. So we are going to cover the basics of the fluid mechanics and Navier stock equation. And after that, we will cover about the open form content also, because we think that means we all, even if you have a advanced experience with the open form. So even if you have a advanced experience with the open form, but we think that some of the participants has the zero knowledge about the open form. So with this thought, we also cover the open form basic structure, how open form directory has been structured into the open form, how solver structure is involved here, how what is the finite value method, what is the message. So everything we start from the basics of the CFD and open form. Then we will also cover the content related to the machine learning. So we think that most of the students who are working on the CFD problem, they have zero knowledge about the machine learning. So here we will also cover the mathematics behind the machine learning. What are the different means packages related to the machine learning, and we will see that what means different theoretical knowledge also we will cover into the machine learning, and we will also do the some practical examples into the machine learning. Then finally we will go to the CFD-ML projects. Okay, so these contents we will cover here, that some projects we are going to take from the real life or industrial problem, and which has the integrated aspects between the CFD and ML. That parts we are going to cover into the module 3. And finally, this is the physics informed machine learning, which is the very emerging topic. So that topic I'm going to cover. So let me tell you about my experience. I have given recently, I've invited to the Brown University. So Brown University is the situated. Brown University is situated in the US. Now I think you can see my screen clearly.
No, we still can't see the presentation mode. Maybe on other end it was visible, but not on what we are seeing now.
Can you see now?
No.
One minute, 1 minute. Now I think you can see the presentation.
Yeah.
Is it okay?
Yeah, thank you.
Yes, thank you. So I was speaking about the pins. So means recently I was invited to the Brown University, And if you know the history about the pins, that is the physics informed machine learning, that is started by the this Kyo Kardashian, which is a professor in the mathematics department of the Brown University. So they are completely working on the pins. So I can say that he is the father of this physics informed neural network. So I was invited to the that institute for presenting one talk related to the pins and CFD. So maybe I can share the link if you want to have some brief idea about that how pins is going to advance the CFD, then you can watch that video. Okay, that is around 15 minutes video. So that topic is this topic, physics informed machine learning, is going to be covered by myself. So where we are going to see the pins concept and what is the difference between the pins and CFD, and we will take some examples. Like when we start the CFD, we will just start with the simple examples like 1D heat conduction problem. So we are going to start pins with this 1D heat conduction problem, and then we are going to compare the pins as the CFD and how they are going to see what is the difference between the results between the CFD and pins. That things we are going to cover into the module 4. So this is the complete modules that we are going to means cover into the this global hands-on workshop. So this is the module 1. So this is going to covered by Abhishek, Nikhil, and Govind. So I'm means going to give the charge to the Nikhil. He is going to cover these things, that what is how he is going to plan, how he has planned this module 1. So Nikhil, mics to you.
I hope I am audible to all of you.
Yes, you are audible.
Yes, yes,
I hope the screen is visible now.
yes,
Yeah. So I am Nikhil Tamboli, presently final year PhD scholar at IIT Bombay, and my expertise is in multi-phase flow. I have developed a CFD code based on level set method, relevant for two-phase flow simulation. And initially I have also worked on OpenFOAM for at least 1.5 years. And as Pratyush rightly mentioned that initially there were no resources to do simulations in OpenFOAM, and we as a student found lot of problems and challenges initially. So this videos by Pratyush in his YouTube channel is quite comprehensive, and he explains everything in quite detail. And in continuation to that, he has also mentioned that the trend in CFD is changing, and people have started using CFD with machine learning. But still, I feel that this CFD in OpenFOAM is quite helpful even for next 5 to 10 years. One of the prime reason why CFD in OpenFOAM is important is, first of all, OpenFOAM is open source software. You can install it in your system without any charges. And also OpenFOAM allows you to learn one of the programming language like C++. And this C++ in OpenFOAM, the object oriented concept of C++ is implemented, which is quite popular in industries as well. So let's go to the details of the module 1, introduction to CFD and OpenFOAM. Initially we will let you know the important concepts that are available in fluid mechanics and important governing equations like continuity equation and Navier-Stokes equation. After that, we will let you know how to do the installation procedure, how to install OpenFOAM in Windows, Linux, and Mac. Then it is very necessary to understand why we are using finite volume approach in open form, because there are certain solvers. In the initial days of CFD, people were using FDM, but now the softwares like OpenFOAM or ANSYS Fluent uses FVM, and the reason is it allows us to solve complex problem, multi-physics problem, which is very difficult if we follow FDM approach. Now after that, when we install OpenFOAM, it's necessary to understand to go inside the folder structures. What are the how is the directory structured inside OpenFOAM? What are the important solvers? What are the important libraries? Then we will let you know how to generate mesh, how to change the boundary conditions, how to change the uh, CFD solution schemes and important schemes. Then after briefing about all the important concepts, then we will go to do one of the simpler problem in CFD and quite common problem in CFD, that is lead driven cavity case. We will let you know how to set up and run uh, lead driven cavity problem. We will also try to change the geometry and see how the result will change. We will let you know every minute details uh, uh, that is required for CFD simulation, whether it's solution setting or scheme setting or control dict setting. Then we will proceed towards a slightly more complicated problem, that is pipe flow simulation, which will be a 3D problem, and we will compute what will be the pressure drop along the length of the pipe. And also Pratyush mentioned that one of the important challenge in CFD is how to simulate the CFD, how to simulate the turbulent flows. We will also let you know what are the differences between laminar flow and turbulent flow, and how to set up turbulent cases, whether it's K epsilon model, K omega model, and other model if possible. After simulating two basic cases, we will go through how to visualize the result, because in CFD there are three important process. Pre-processing means mesh generation, uh, that we will learn, and then processing means how to run the simulation, that is the solution of the Navier-Stokes equation. And then the third part is post processing, that is what to do if we get the CFD results. So in post processing, we will visualize important contours, streamline and line plots using ParaView software. After that, after doing the basic stuff, then we will move to solver development part. We will start with one of the basic problem, and then we will try to modify the existing solver from the uh, OpenFOAM installed solver directory. Then we will also going to learn how to automate the workflow with scripts, how to use PyForm scripts for the batch operations. So, uh, so this is further a detail of the CFD part in OpenFOAM. As I have mentioned that we will start with C++ coding in OpenFOAM with a very basic example of Hello World, and then we will also going to perform basic mathematical operations. Why it is necessary? Because when we do some CFD simulation, it is necessary to do the post processing. Post processing means, let's say we want to calculate the, for example, in case of heating problem, let's say if we want to calculate the Nusselt number, there are possibilities that there is not direct calculation of Nusselt number available in OpenFOAM. So we have to formulate and code that Nusselt number calculation in our own in-house code, in our own CS, this OpenFOAM in-house part. So this thing we can also, that's why it's necessary to do the C++ coding in OpenFOAM, relevant in case of post processing. So the important concepts will be covered, like fluid dynamics and CFD theory, finite volume method. And also it is to be noted that this OpenFOAM is initially built for Linux operating system. So when we deal with OpenFOAM, we need to learn some of the prerequisite Linux command that we will going to cover before performing the CFD simulations. And then again going through solver libraries and tutorials. So OpenFOAM comes with its inbuilt tutorials that allows us to understand how to set up the problem, but these tutorials are very basic. So for more advanced problem, there is a need to modify the tutorial that we will also going to do in our workshop. Then, as I have mentioned in the pre-processing, we have mesh generation utilities called block mesh and snappy hex mesh. The block mesh is generally used for in order to create very simpler mesh, but for complex mesh like flow or aerofoil, we don't use block mesh, we use snappy hex mesh. So the details about how to create a mesh for flow or aerofoil will be deeply covered, and it utilizes snappy hex mesh utility. Then we will also going to understand the CFD iterative algorithm, because what happens here, we are solving Navier-Stokes equation and continuity equation. So one of the important challenges, there are more unknowns than the equation, so it requires use of iterative algorithm. So three important iterative algorithms are available in open form, that is simple, piezo and pimple. In today's session, Pratyush will go through the simple algorithm in detail. After that, discretization schemes. So if you look at the Navier-Stokes equation, there are various terms: temporal term, advective term, diffusion term, and source term. So how to discretize each of the term is very important. So one of the important test problem is the test of advection, and this test is called false diffusion test. In this test, we can check various advection schemes used in the CFD simulations, and then we will go through the solution schemes, and also we're going to understand the simulation from its control parameters, like what should be the delta t, and for how long time the simulation will going to simulate, what would be the saving file interval. So all these smaller things and the smaller details will be covered in this discretization, solution scheme, and control parameter session. So, as I have mentioned in the previous slide, the hands-on will be on lead-driven cavity problem, where we will teach you how to set up the case. Then we will give you another changed problem, and you have to perform the simulation and then post-process the result. So there is one more part, that is solver modification. So actually, why we use OpenFOAM is because one of the important reason of using OpenFOAM is because it allows you to modify the existing code. You can make any customized solver as per your need. For example, let's say if you want to simulate multi-physics problem that involves electric field or magnetic field or porous media or moving boundary, all the modules can be separately added in the existing solver. So in order to do so, we need to start with very basic problem. And one of the basic problem is how to add temperature equation to the lid driven cavity problem, which is initially a hydrodynamic problem. So we will going to add temperature equation to the lid driven cavity problem, and we will going to visualize the result in ParaView. And then there will be a advanced session on fluid structure interaction, multi-phase flow simulation, dynamic mesh motion, rheology toolbox, and also a porous media, flow inside a porous medium. So this will be the entire CFD topics that we are going to explain you and make you do the hands-on in details. So this is all from my side from the CFD uh, in open form. Over to Suraj for further details on machine learning based CFD. Thank you, all of you.
Thank you so much. I'm sharing my screen. Am I audible?
Yes, yes,
Yes. My screen is visible.
yes, yes.
Okay. So my name is Suresh Acha. I have completed my BTech from IIT Bombay and also currently pursuing my PhD in machine learning and healthcare. At the same time, I'm also working in Bharat Gen, which is India's first LLM-based company, which is we are building foundational models in LLMs. So I'm an AI researcher and consultant, and also do consulting for various other firms. So that being my background, so we all know that machine learning has become an important part, especially machine learning and AI has become an important
Suraj,
part,
can
and
you please
almost
hide this? Stop sharing the thing. You hide that.
yes, yes. Now it's better. Hmm.
Yes, yes.
So we all know that machine learning and AI especially has become an important part in everything, like practically everything. Even Pratyush was mentioning that having machine learning on your CV makes it so more appealing to the recruiters for postdocs and so many other positions, because it's like one of the needed things. It's a salt in the food where it is needed in every other place. So we also decided that there should be a dedicated module for machine learning in general theory and machine learning for fluid dynamics also. So myself and Kundeshwar will be taking the machine learning module. In this, what we'll be covering is a bunch of things. First of all, we'll also look at the overview of the whole machine learning situation, and then we'll see the theory, we'll see a lot of examples also, especially because for our domain, classification and regression uh, becomes very prominent. So we'll go into the theory, go into algorithms and use case applications of classification and regression. Then we'll, of course, because many of us may be starting from basics, so we'll not skip the basics. We'll also teach the basic Python installation of VS Code, how which libraries are important, and how to set up the whole ecosystem for coding. Then second most important thing is, because we deal with so much data, then data pre-processing becomes very important, because see, we get data from normal any experiments, but then pre-processing it becomes important, because we do not want to have for example, outliers. What are outliers? What are null values? Then what all data to keep, what all data to not keep, and even the data which we have, how to actually pre-process them. Then we'll not only look at theory, but we'll also look at hands-on, and especially we'll focus on. So we'll look at a lot of algorithms, but at the same time, we'll especially focus on decision tree and random forest in detail, and we'll also have validation techniques. What is validation? What is overfitting? What is underfitting? How to train a model, then how to visualize the model in graphs, because finally we want to present to a layman. Then a layman will not understand all the models, they have to be presented with results, graphs. So how to even do that. Then the hot topic, that is neural networks and transformers, which also includes a touch of LLMs, because see, the whole domain, how the whole machine learning field is evolving. We do not know what new skill or concept will become relevant tomorrow. So that is why we also decided that okay, we'll teach the latest technology in machine learning, which is transformers and LLMs. We'll touch upon it so that we are aware about how the world is functioning. We are aware about the basic theory. So let's say you completed this course and tomorrow a new technology for transformers and LLMs comes up. So we are not completely alien to that. So we also have a background in LLMs and transformers, and we will be very able to easily adapt to that. And how it will work is, so we'll cover a bunch of important topics which I have already listed in our last module, last slide. But the modularity is also important. So we will look at theory and concepts, because that serves as the foundation. Then we will also look at the intuition behind the algorithms, because see, machine learning has 1,000 algorithms, but we may be covering only a few. But at the same time, if you understand how those algorithms were developed, what is the thought process or intuition that goes behind it. So right now we are covering decision tree and random forest, but after taking this course, because you know the intuition behind working that, uh, let's say you discover some another algorithm which is also relevant to your problem statement, then you will be able to easily adapt that. And obviously we'll look at the mathematical foundations, because if you want to make some changes in the algorithms, that requires you to understand what is the formulation first of all, what is the optimization function first of all, so that you can make the changes effectively. And finally, the use cases, how to implement those, how to code it. So that brings us to the third part, which is the hands-on. We'll first of all have the Python installation of various libraries, setting up the environment, everything. We'll be using VS Code for this. Then we'll have an hands-on on viscosity prediction, and then also have an hands-on on synthetic fluid property data. In both of this, we'll do a lot of classification and regression problems and see how the theory gets translated into application. And then finally, we'll also have hands-on on visualization. What is the best practice to present, uh, and how to actually code those graphs? What are the key features for each graphs? Because in papers we see all those beautiful graphs coming, but I used to actually personally wonder from where these graphs are coming. Then I did the Google Data Analytics program course, which is a very big course actually. It goes on for half a year, and then many concepts got cleared. Okay, what are the best practices to present graphs, visuals, what plots to use? So these are the important things we'll be covering in the machine learning aspect. In summary, this will include both theory and theory in general, theory relevant to our domain, and also its practical use cases. Thank you so much, and I'll request the next speaker to come in.
Yeah, Abhishek, module 3, can you take over the mic?
Yes, yes, yes. Thank you, Pratyash. I'll take over now. I hope my screen is visible and you are able to see my slides changing.
Yes.
Yes, yes.
Okay. So hello everyone, my name is Abhishek. I have done my master's and PhD from IIT Bombay in NSYS as well as in the in-house code that we have in our lab. And right now I'm a postdoctoral researcher in Department of Applied Mechanics and Biomedical Engineering in IIT Madras. So here I work on bio-inspired drones using OpenFOAM. So one of the important aspect of machine learning nowadays is how can we achieve machine learning based active flow control. So most of the flight that you see nowadays are such as aircrafts and drones are controlled by some human intervention behind it. But nowadays machine learning based active flow control has is being studied very heavily. And so for example you can see here aerofoil which has been morphed on the spanwise direction, and it is a basically a flap. So using machine learning based active flow control, this flap can be used to change the flow, which can help in drag reduction and lift enhancement, and maybe improve the stability and maneuverability of the aircraft or drone wherever this aerofoil is used. So people have also not nowadays they are also studying this like active giving active flexibility to the aerofoil using some actuator mechanism, and they are also trying to do a lot of CFD on it. CFD, and so the basically the idea is either we can use flexibility morphing aerofoil, or we can use active jet control to somehow change the boundary layer development and flow separation control. So understanding the physics using CFD and then implementing machine learning based on that is very important nowadays to like actively control the wing. Now on the left you can see a unmanned aerial vehicle which needs a runway to take off, and let's see. And here you can see a drone which can like can take off vertically. And nowadays people are working too much in this VTOL, that is vertical takeoff landing. They are trying to implement this. So for better stability and maneuverability of these things, what nowadays research is being done is to use AI to achieve stability and vertical takeoff and landing. So this is very important in new research in this aspect, that is CFD combined with ML. Now, if you look at deep reinforcement learning, so how do we achieve active flow control? So this is one of the basic this is one of the basic deep reinforcement learning algorithm in which through which we can achieve an active control. So here you can see a flow. For example, if you want to reduce lift and drag on this cylinder, so we have a open form environment in which simulation is done. We provide the DRL agent the flow field information and drag and lift coefficient. It updates the state, and then from these parameters, there is a reward function. Okay, so based on the state and the reward function, the agent will take an action, and that action will be implemented as a new input to the open flow environment. This is simply how it works. Basically, in this case, we want to maximize the reward function. So in other cases like uh, simple uh, simple learning, machine learning, in most of the cases we want our weighted residues to be minimized. Here we want our reward function to be maximum. So based on this, I have like proposed 3 or 4 projects. So one of them is predicting flow field from cylinder wake using supervised deep learning. So these are actually very basic project which you can do in this workshop. There are very advanced level of project in machine learning and CFD, but these are very good to get you started with CFD and machine learning coupling. So in this, what we'll do is train a convolution neural network to predict velocity field behind a 2D cylinder, and then predict the flow. When we predict the flow, and then we'll try to predict the flow at different node. First we train, and then we try to predict the flow field, and then we compare the results and computation expense. So what happens is, when you train a model, then you try to predict at different input parameter, the computation expense is very small. So we'll see all that. So this is the first problem. Uh, Second is active drag reduction of a cylinder using deep reinforcement learning, in which we'll have 2 jets on top and bottom of the cylinder, and the DRL agent is trained to maximize the reward function and achieve drag reduction, or we try to suppress the vortex shedding. So we find, so this DRL will try to find an optimized jet flow and its transient behavior. Apart from that, we have like uh, for urban buildings and bridges, it is very important to find the flow field in the urban cities and also pressure distribution on this bridge. So what we want to find here is for different velocities, with different magnitude of velocities and its different angle of attacks, we want to find how the pressure distribution changes over the bridges. These are also a bit advanced projects, but yes, we can also touch upon these. This urban wind flow prediction is we can touch upon. So these two are very basic project. Will for sure cover the more projects we have in mind. But once you guys register, then we can discuss like at the end of the workshop when we'll move toward this CFD-ML project. Then we can discuss your idea as well, like what you want to do. So this is from my side, and hope to see you in workshop soon. If you have any doubts, you can ask at the last of this session while we are presenting about this workshop. Thank you.
Yes, thank you, Abhishek. Thank you, Nikhil, and uh, thank you, Surajji. So
Any
basically,
questions you can ask now.
yeah. So you can ask the question at the last. So we have means Nikhil has speak about that what how we are going to plan about this module one. So these are the structure related to module one, and module two is covered by Surajji. So remember that Surajji and Kundeswar both are working on the Bharat Jet, which is the one of the important project where IIT Bombay CST department is working on. So they are the members of that Bharat Jet project. So they have very good knowledge about the machine learning. So they know how you can learn about how you can even from the theoretical perspective and even from the hands-on perspective, they have a very good knowledge about the machine learning. That is why we have means asked them to cover this topic, that is the module 2. And this CFD ML content that uh, Abhishek just explain about that. What are the different projects we are going to cover? But that is not limited to only those 3 projects. We are going to have some other projects. When you going to join this workshop, then we will create means 1 or 2 sessions just to decide that what are the projects we are going to cover in this CFD-ML workshop. So just that 3 project, he just given idea that how what are the different 3 projects that is the related to the our workshop and our hands-on workshop. But other projects we will discuss and we will discuss. See this workshops, whoever has joined our first workshops, they know that we don't work like a student and teacher relationship. We When we start workshop from the day one, within 1 week you will develop a relationship between the mentors and ourselves, and we will just like a family. So we just ask from you that what contents you want to repeat, and here we are saying this as a just a 48 hours lectures, but it is not limited to 48 hours. If you require that we want to explain some topics more and more times, we are going to do the same also. Okay, so this topics is also decided once you join this program, but that is why I have not included much of the slides about the module 3. Now this third topic, that is the physics informed neural network. So starting from the basics of the pins concept, that I'm going to give you the why pins idea of a pins comes into the picture, and why this we are going to compare between the pins and CFD. And we are going to first start with the 1D conduction problem, which we will do using the completely using the physics informed neural network, and we will plot and train the pins models. And also I'm going to take see pins also in means pins also integrated with the data that is already present and physics. So we will, for that purpose, we are going to integrate with the open form tutorial cases, and we are going to learn that how open form already built up cases can be used to train the your pins model, and we are going to finally compare the accuracy and runtime. Okay, so these things we are going to cover by myself and Dr. Srijna Singh, who is currently a postdoctoral student working in the Shanghai Institute of Technology, which is situated in the China, and she is also working on the pins problem. And so if I want to give you just overview about the difference between the conventional method, that is the mesh-based method. CFD is sometimes known as the mesh-based method, and the pins is the physics informed neural network. So if we want to compare here, so see, there are lots of comparison that can be done, but some of the important points I have, important aspects I have mentioned on the slide. So if you see that in mesh-based method, we solve piecewise defined polynomials. Means first you create the mesh on a given problem, and between the two cells, we assume that there is a one polynomial. It can be either one linear polynomial or it can be a second order polynomial. So this is assumed from our side. So that assumptions we first take, then we solve our problem. But in pins, this polynomial function is taken care by the neural networks. So that is advantage between the mesh-based method and pins method, because here that polynomial is assumed or solved by the some neural network structure. But here we are already imposing a condition that between the two cells, this type of polynomial is defined here. Either it could be second order or it could be the linear polynomial. So this is the one aspect. Second is that here we assume as a fixed value at the discrete point. So we take some mesh and we assume some field value at a different discrete points. But here we solve the neural network, and we are going to train about the weights and biases. Okay. So when we are going to cover this topic, then I think some of you are going to relate at that time. But this time maybe you are not able to catch these things. but some things that you are going to understand here, because like if you speak about the mesh requirements, so if you are using the CFD, the mesh requirement is the very important thing. If a complex geometry, the mesh becomes the very complex mesh generation is required here, because if your mesh is not good, then you will lose the accuracy, or sometimes it happens that you are not able to get the purpose solution. But in points, this mesh problem, but when you are going to use the pins, this mesh problem is not any hectic task here. Here pins is not mesh is not required. And why mesh is not required here? That we are going to see when we are going to learn about the pins. Okay. Here the in both cases we solve the partial differential equation. Partial differential equation. Here we use the discretized form of the PDE. But in case of the pins problem, we generally make this partial differential equation into the sum of the optimized problem. So here we try to use that partial differential equation as a loss function, and we are try to minimize that loss function. And that is why we generally sometimes say that pins is a optimized problem, whereas in case of the CFD or mesh-based method, we say that it is the discretized equations. Okay. Here we use the numerical solvers, and here we to reduce the loss function, we use the gradient based optimizers. Okay, here are the, if we compare the sources of error, here are the different discretization error, stability error, and numerical dispersion sometimes, which is because of the either the polynomial assumptions that we are taking between the two cells, or sometimes due to the miss. So this numerical dispersion is the another source of error. But in case of the pins, the errors generally uh, due to the neural network and due to the data accuracy, and that is the optimization challenges. So these are the some comparison between the mesh-based method and pins method. Generally, because if you see the industry and real life examples, so in real life example and industrial problem, two things is generally required. One is the fast solution, and second one is the, because in real life example the geometry is the very complex. That is why it is going to require the complex meshing also. So that is why if you see that this mesh-based method is not, that is why industries are focusing to find some pins kind of solution where they don't have to do the meshing of the complex geometry. So that is why currently this pins is means most of the industries focusing on the pins kind of a solution, and that we are going to see in our pins session. So this is all about our 4 sessions, 4 modules, and we have give you some idea about what are the things we are going to cover into the different 4 modules. Now, speaking of the course plan, so we are starting this course from the 15th July, and we are going to have a 3 sessions in a week, and this 3 session will be take place from the 6 p.m. to 9 p.m. And remember that this is not rigid, means this time is not limited, means very, this is not very rigid timing. We are going to form a group. Once you register for the course, you pay the fee. We are going to form a group, and as I said that we are going to work as a family, and we will decide that which is appropriate time. And in last workshop also, we sometimes we take classes on the weekdays, sometimes we take classes on the weekends, and sometimes we continuously take classes on the 3 days or 4 days. Sometimes complete week we have not a single classes. So that we discuss in the WhatsApp group. But this is just a plan that we are going to follow, and this is going to be around 40 hours of the interactive sessions, where we are going to provide you mentorship. We are going to discuss, even if you are working on some project related to the CFD-ML and we are facing some issue, we are going to help you out. Not we are going to work on your project, but if you are facing some issue, then we are going to help you out during this session. And apart from this course plan and these things, we are going to provide you free access to 40 hours open form programming sessions that we have recorded in the last year that we are going to give you a free of cost if you are going to join this course. The cost of that course, that open form advanced programming tutorial, is around 8,000. So after the finishing that session last year, I have sold around more than 30%, 30 people this course. This open programming session, I've sold around more than 30 people. I have sold that course. So you are going to get this course at the free of cost if you are going to register for this course. And also this lifetime membership we are going to give you. So this lifetime membership, if you are a member, then you will always going to get some discount to if you are going to plan some new courses. So you are going to get that discount if you are a lifetime membership. So if you are going to register, you are going to be a lifetime membership of the ITRAC. Now this is the fee structure. So if you are Indian participants, so this is the early bird and this is the regular fee structure. So we are going to give you up to the 5 July. You are going to register at this price. And if you are going to register after the 5th of July, then you have to pay this amount. And this is for the international participants. So if you are going to register as an early bird, you are going to pay this amount. If you are going to register as a regular, you are going to give this amount. And this is the members who have already attended our last year course. We are going to give you 50% discount at the these two prices. If that ITRA lifetime member is going to register as early bird, we are going to give you 50% discount at this price. And if you are going to register after the 5th of July, then we are going to give you at this price. Now some participant has asked me that whether I can get this recorded lectures after the session is going to be finished. So remember that I would never recommend to attend to get the pre-recorded lectures, because I'm also once that time I'm also learning these courses from the internet and from other resources. So I have experienced that when you do the live session, you learn faster compared to the if you are following some recorded session. So I will advise that if you want to learn this course, register for the means running course. Don't think about the pre-recorded session, because it is not effective, because we are engineers, we always think of that I can do later, I can do later, I can do later. So this is mindset of every engineer. So if you want to attend this course, just run the running course. And even if you see the price differences, so like if you see about the last year our training courses on open book programming, we have just given only 5,000 difference between the means complete workshop and the pre-recorded session. So like it was around 12,500 if you were attending a live session, and if you were getting the recorded session, then we have kept the price around 8,000. So the only difference is 5,000. So it is not advised that if you wait for the pre-recorded session. It is always advised to attend the live session and have fun with the live coding, and have fun with the live interaction with the mentors. So I will recommend you to the join the course before the 15th July. And these are the team members, and this is myself. And currently I'm going to soon I am going to work as a postdoctoral fellowship at the ATFGD. He is Abhishek. He is currently working as a postdoc fellow at IIT Madras. He is Govind Maurya. He is also working as a postdoc fellow at IIT Bombay. And she is Dr. Sijna. She is currently postdoc fellow at the SJTU Shanghai. She is going to be a mentor for the physics informed neural network. And these two guys, that is the Suraj and Kundeswar, they are going to cover the topic related to the machine learning, because they are uh, they are very master in the machine learning. I can say that because they are working on the Bharat Gen project, which is the one of the government initiative, which is being led by the IIT Bombay. And these two are working under the Professor Ganesh sir, and you can search that professor profile. He is a very so recently he is that professor is listed into the Forbes 100 a guy of the world who is working, who is making changes in the AI/ML. So that professor is listed in that Forbes 100 list. So these two guys are working under him, and they are very master in the machine learning. So this is our team who is going to coordinate this CFD/ML content. And if you have any questions now, we can ask question related to this workshop only. So please raise your hand, and then I will allow to ask. No, Lewis, you cannot take the course separately. You have to register for the full complete course. Yeah, Kumares, you can text me in the personal on the WhatsApp that you want to work as a collaborative. Then please text me on WhatsApp in person. Any other question, you can raise your hand and I will allow you to speak. Any mentors want to say something? Any of members from our team want to say something? Yes, Soumya, I think if you are in the group, we will share you the details how to register for the course. This was just a orientation session, just about the. Yes, Saurabh. Speaking about the time, as I said that this is the means when you register this course, we are going to discuss in the group whenever we find a suitable times according to everyone, every participant, we are going to fix that time.
Hello.
Yes, Abhishek.
I just want to say a few words. So we as an ITRASIM like group of people at IIT Bombay, PhD researchers, uh, we have conducted many workshops of CFD, open form and NSYS. I just wanted to say to you all guys that the course that we are presenting here, if you are able to successfully complete it for 2 or 3 months, you will not be a very high expert in CFD and ML, but you will have the idea of the field and how to navigate every possibility that is there in CFD and ML. So for any PhD researcher or any researcher that who is working in any lab, it takes a year, maybe 2 years to get the hold of, to get the idea or to learn what we are presenting in this course. So if you are registering it, it will be like saving, it will be as an expert will guide you and will save a lot of time of your time when you start to learn CFD and ML. So in 2 months of workshop will teach you like 1 month, 1 year of content worth. So if you really want to learn, I think this is the best opportunity in India that I've seen who teaches this combination of CFD and ML. So if you have any doubts, you can reach out us on the group, WhatsApp group, and we'll let you know or we'll clear our doubts. Thank you.
Yes, as Abhishek said that means anything it means whatever the topics we are going to means whatever the courses we have proposed till now, even if you see about the basic open form and even if you see about the advanced open form and even the NSYS content, you can ask any participant. Some of the participants already in this group group orientation group, and you can ask them the content we provide. When after the attending the course, when we compare with the price, you are going to always say that this price is very less. So when we finish that open form content, one or two participant from that course personally text me a message, sir, your content is even if you ask us double money, we have registered for that course. And let me tell you, means one of the professor from the MNIT Prayagraj, she asked me that course that we have completed an open form program. First, she asked me that whether whether I'm paying genuine amount or not, because she has already cheated by many of the content provider related to open form. So she has been cheated by many of them. So she called me and she said that this is the issue. I have already cheated by many people. So I have given her the content at the free of cost at the starting. I said that you just go through it for 2 3 days, and when you feel that my content is genuine, then you can pay me. So then she after visiting that content, she called me and she said that I can give you around 16,000. You are asking what only 8,000. I said that no, I need only 8,000 because this is the price. So after that means after attending the content, you can compare with the any of the resources provided online or anywhere. You will always going to find our content is the best. So that is from my side. Yes, I will share you the complete PPT into the group. So don't worry about this. And also I will share you soon, maybe by the end of the today or by the tomorrow afternoon, how you are going to register for the course and how you are going to pay the fee. Okay. So I will going to share you the slides as well as the recording video will be also shared with you. And how to register for the course, that is also we are going to share in the group as very soon. Okay. If you have no any questions and if any team members don't want to speak anything, then I think I can go for the second session. Okay. So let's start with this session. Let me first close